Alright, so this video is going to go over basically looking at rational and radical expressions and looking at the relationship so that we can solve whether it be in rational form. So kind of keeping in mind that this would be considered rational because it has an exponent that's a fraction, and then this would be considered radical because it's still in radical form. We haven't decided what the root is, but we know that's in radical form. So what we want to see here is that when we're taking a look at, we come across a radical form, that there's an understood 2, and the exponent is 1. So when we convert it to rational form, this is going to be my exponent, and this is going to be my root. Whereas this number out here is called your root, and of course that number right there is called your exponent. And so we have another example there of the same thing. Let's take a look at, for me, looking at the examples probably helps the most. So here's a couple. If you want to hit pause and try it yourself and then come back and watch it, that would be a great technique. I want to put this into radical form. So this would be the square root of 7 to the first power. And then you could or could not, you don't have to put the 2 right there, but it is understood. So normally you would just say the square root of 7 to the first. In this case right here, this would be 2. We'd have a 5 right here and a 3 right there. This one would be the square root of 6 cubed squared, and so forth. So you can kind of keep on practicing and see. I'm not going to go over those last ones. But now if we go to the other way, what if we go from radical to rational or to exponential? So on number 7, remember you can always hit pause and work them out yourself ahead of time, and then unpause and watch and see how you did. So this would be 10 to the 3/2 power. This would be 2 to the 5/4 power. And this would be 2. Remember there's an understood 1 right there. So this would be 2 to the 1/3 power. Alright, so that is to kind of establish what's going on if we come across now and had to solve something that was in rational form. So you kind of could make a relationship between what was really going on here and understand why we're doing this. In the problems that we're given here to start off, we're told that we have x to the 3/2 is equal to 8. And so the reason that I brought the radicals in a minute ago is because what I want you to recall is we just left radical on our first video in our first set of problems. We had situations where, for example, we had the square root of x is equal to 8, and we wanted to solve for x. So the opposite of square root would be to square. And so, and whatever we did to one side, we do to the other. Well, the reason that works is because what you really have right here is you have x inside the parentheses right here. That's x to the 1/2 because there's a 1 right there and there's a 2 right there. So when you convert this radical form to exponential form, and then we realize that by squaring it, what we're really doing is we're multiplying by the reciprocal. So when you multiply by the reciprocal, what happens is it's not so much that the square root and the square cancel. It's that when we follow the properties of exponents, at this point we would multiply those together. Well, 1 times 2 is 2, and 2 times 1 is 2. And so that's x to the first power is equal to 64. So it's not that they cancel each other out. It's that when you square this, you're multiplying by the reciprocal. And then when you take care of your properties of exponents and you multiply those exponents together, your exponents are actually simplifying to a value of 1. So where am I going with this? I'm going to the way that we solve this is we multiply by the reciprocal. We take whatever fraction we have right here and we multiply by the reciprocal, because now what happens is we have a 2 on the bottom and a 2 on top, and we have a 2 on the top, or a 3 on the top and a 3 on the bottom. So basically what happens is I get x to the first. Now if that doesn't quite sink in for you, think about it this way. 3 times 2 is 6. 2 times 3 is 6. Don't forget, whatever we do to one side, we have to do to the other. So that becomes 8 to the 2/3, and then we know 6 over 6 turns to 1, and then we pull our calculator out. Oop, let me hit pause real quick and get my calculator. Okay, so we got our calculator, so now we would take 8 and we would raise it to the 2/3 power, and that tells us that our answer is 4. If you have a TI-83, the way you'll have to do that is you'll have to do 8 caret and I'll tell you what, don't worry about what I'm doing right now, okay? Like, don't be like, whoa, what's that guy doing? I'm just changing my calculator around so that way it'll look like a TI-83. So if you had a TI-83, you would do 8 caret open parentheses 2 divided by 3. So that'd be the correct way to plug it in the calculator. And so you get your 4. Alright, so that would be taking care of a situation where I had just, one variable. Well, nothing really changes when I move over here to one of these other examples. So if I came over to this guy right here, and I started looking at this, the same thing applies. I need to get to the stuff that's inside this radical. So how am I going to get inside there? Well, I need to undo this exponent. Well, how do we undo that? Well, we have x squared plus 78x raised to the 1/5 power is equal to 3. Well, we know that if we want to get rid of an exponent, we just take and multiply or raise that entire thing to the reciprocal power. And whatever we do to one side, we have to do to the other side. Now notice I didn't put 5 over 1 because the 1 doesn't really apply. It doesn't do anything for us. So on this side, the 5's cancel, the 1's cancel, and that leaves me with x squared plus 78x equals, pull my calculator out, 3 to the 5th power, 243. At this point, I'm hoping that what you're seeing is, you're seeing a quadratic, seeing an x squared, and you know that in order to solve a quadratic, you must move everything to one side. So now I have x squared plus 78x minus 243 is equal to 0. And that's we're in the beautiful form now. Beautiful, I say. We're in the form now where we can use the quadratic formula. You could definitely guess and check. You could use bottoms up, but I'm going to stick with quadratic formula. So at this point, we know that our a value, our b value, and our c value. So we know that our a is equal to 1, our b is equal to 78, and our c is equal to negative 243. So we start plugging things in. Alright, let's change to blue. So x is equal to a negative 78 plus or minus the square root of 78 squared minus 4 times a times c. All of that over 2a. Okay, remember what I asked before? I asked that, to be safe, we plug into our calculator what's on the numerator. So I do 78 squared minus 4 times 1 times negative 243. So that means that under my radical, I have x is equal to negative 78 plus or minus the square root of 7,056 divided by 2. Remember that the quadratic has both a plus and, let me give myself a little more room, and a minus. So now I take my calculator and I do those as two separate pieces. So I like to use my fraction key. So alpha y equals, choose number 1. Oh, let me hit pause for a second and turn my mode back. Alright, so alpha y equals, choose number 1, type in my numerator, plus the square root of 7056 over 2. Press enter, and it tells me that my plus is 3. So I go down and do it again. Remember the way the TI-84 works is that I can just arrow up. If you have a TI-83, you just need to retype it. But once you arrow it up, you can move yourself back across. And you can just replace that plus sign with a minus sign. Press enter, and I get negative 81. So what does that mean? That means in relationship to the conversation, I know that my x could be equal to 3, or my x could be equal to negative 81. Those are the two numbers that make my inequality or my equation true. All right, so that's how I'd solve if I had a rational exponent in my equation.